In this video, we are going to look at the problems in the Chapter 10, Section 5 slides. We're starting here with this problem where we're asked to find the number of proper subsets of S equals the set of A, B, C, D, E, and F. Now, we remember this from our from Chapter 2, when we were talking about the number of subsets of a set. The number of subsets of a set is 2 to the n, where n is the number of elements in the set. But that doesn't give us the proper subsets. It gives us all of the subsets. So to find the number of proper subsets, we're just going to subtract 1 from that. So the number of proper subsets of the number of proper subsets of S is 2 to the 6th power minus 1, which is 64 minus 1, or 63. Moving on. If 4 fair coins are tossed, in how many ways can at least one tail be obtained? Okay, so here we need to know how many ways there are that we can have at least one tail. Well, that means that at least one tail is the same as not all heads. Well, there's only one way to get all heads. To get all heads, we just have to flip 4 heads. So we need to figure out how many possible ways there are to get to flip 4 coins, and that's going to be 2 to the 4th, which is 16. And then we'll subtract 1, because that one accounts for our one case where there are 4 heads. So 15 ways to get at least one tail. Carol and 3 friends are boarding an airliner. There are only 10 seats left, 3 of which are aisle seats. How many ways can the 4 friends arrange themselves in available seats so at least one of them sits on the aisle? Well, at least one of them sitting on the aisle means that at least one of them is in one of those 4 seats. So we say that for the first person to sit down, there are 4 choices. Okay, well, that takes away one of the other, one of the 10 seats, and there are 9 seats that, 9 seats to account for left over, and then 7, and then 6. Sorry, 8, and then 7. So we've got 4 times 9 times 8 times 7, which we can easily multiply, ideally with a calculator, because we don't want to mess that up. 4 times 9 times 8 times 7 gives us 2,016 ways so that at least one of the friends is in an aisle seat. Okay, how many 5-card poker hands consist of either all clubs or all red cards? Okay, so the first thing we want to do is figure out how many all club hands there are. All club hands, well, there are 13 club cards to start with. And then once one of those is picked, there are 12 to start with, times, I feel like this is this is not the easiest way to do this. The best way to do this is we've got 13, choose 5. Okay, well, that's 13 factorial over 13 minus 5 factorial times 5 factorial. So that's 13 times 12 times 10 times 9 times 8. Times 11 times 10 times 9 times 8 factorial over 8 factorial times 5 times 4 times 3 times 2. We can cancel that and that. We can cancel the 5 and 2 to get rid of the 10. We cancel the 4 and 3 to get rid of the 12. We're left with 13 times 11 times 9. Which gives us 1,287. Now, for the all red cards hands, we have 26 cards to start with. That's 26 choose 5, which is 26 factorial over 26 minus 5 factorial times 20 times 5 factorial. Okay, well, that's 26 times 25 times 24 times 23 times 22 times 21 factorial over 21 factorial times 5 times 4 times 3 times 2. Okay, well, we can get rid of our 21 factorial, factor a 5 out of that 25, and then 4 times 3 times 2 is 24. So we're left with 23 times 26 times 22 times 5. That was a bit out of order, but it's not going to make much difference. 23 times 26 times 22 times 5 gives us 65,780. Therefore, the number of 5-card poker hands that consist of either all clubs or all red cards are 1,287 plus 65,780, which is in total 67,067. This table categorizes a diplomatic delegation of 18 congressional members as to political party and gender. If one of the members is chosen randomly to be the spokesperson of the group, in how many ways could that person be a Democrat or a woman? Okay, well, the way we want to do this is figure out what number of possibilities there are for a Democrat or a woman. We've got 10 Democrats here, and then 3 additional women who aren't Democrats. That's 13 ways. Sorry, that was 13 13 women who aren't Democrats. Chrissy needs to take 12 more specific classes for a bachelor's degree, including 4 in math, 3 in physics, 3 in computer sciences, and 2 in business. If 5 courses are randomly chosen for next semester's program, how many of the possible selections would include at least 2 math classes? Okay, well. The way we do this is to figure out how many ways there are to choose these classes overall, and then determine how many don't have at least 2 math classes. That is, have only 1 or 2 or 0 math classes. Okay. Overall, we've got 4 math classes, 3 physics classes, 3 computer science classes, and 2 business classes. So that's 4 times 3 times 3 times 2 gives us 108 total schedules that that's 100. Five courses are randomly chosen from next semester's program. Okay, so I'm doing this wrong. I apologize. We need to choose 5 classes from the original 5 plus 4 plus 3, 4 plus 3 plus 3 plus 2 is 12. There are 12 classes, and we need to choose 5 of them. So 12 factorial over 12 minus 5 factorial times 5 factorial gives us 12 times 11 times 10 times 9 times 8 times 7 factorial over 7 factorial times 5 times 4 times 3 times 2. Cancel those, cancel our 10 and our 12, and we're left with 11 times 9 times 8. Which is 792. 792 classes, or possible schedules. Now, we ask how many of those have 0 math classes and how many have 1 math class. Need something, where is it? There it is. There we go, sorry about that. Been a while since I did this problem, so you know. Okay, here's how we handle this. So we can do this. We can take 4 choose 1 times 8 choose 4. Yes. These are the 4 math classes that are available, and we're only picking 1 of them. These are the remaining 8 classes, and we're picking 4 of them. So that's going to be 4 choose 1 is just 4 times 8 choose 4 is, of course, 8 factorial over 4 factorial times 4 factorial, or 8 times 7 times 6 times 5 over 4 times 3 times 2 times 1. again, times 4. Okay, well, that gets rid of my 8. There's that. So this is now 2 times 35 is 70. And then we can do 4 choose 0 times 8 choose 5. Okay, well, that's 4 choose 0 is 1 times 8 factorial over 5 factorial times 3 factorial gives us 8 times 7 times 6 over 3 times 2 gives us 56. So 56 plus 70 is 126. We subtract this from our 792. We get just checking the book here. That's some math wrong. It's 126, 790. There is an easier way, there is a different way to do this. I'm not going to say it's easier, but it comes up with a different answer. And I think that I calculated wrong the number of ways there were to get 5 classes overall, maybe. Or just multiplied wrong. That's always possible too. I'm just going to quickly grab another page and show you another way to do this because I messed up and I apologize. This is the way the book does it. In the book says to take the possibilities for choosing 2, 3, or 4 math classes and add those up, and that will give us the number of ways of taking 2 or more classes. So we have 4 choose 2 times 8 choose 3. Okay, well, that's going to be 4 factorial over 2 factorial times 2 factorial times 8 factorial over 5 factorial times 3 factorial, which becomes 4 times 3 over 2 times 8 times 7 times 6 over 6. Left with a 2 there, so that's 6 times 8 times 7. 6 times 8 times 7 gives us 336. Then 4 choose 3 times 8 choose 2 becomes 4 factorial over 3 factorial 1 factorial times 8 factorial over 6 factorial 2 factorial. Okay, well, this is just 4 over 3 factorial, which is 4 factorial over 3 factorial, which is 4, times 8 factorial over 6 factorial will give us 8 times 7 divided by 2. So that's a 4 times 4 times 7. So 16 times 7, which is 112. And finally, we do 4 choose 4 times 8 choose 1. There's only one way to choose all 4 classes, and 8 ways to choose one of 8 classes. So that's 32. Slipped up a bit. Okay, so then we take those 3 numbers, 336 plus 112 plus 32, and we have a total of 456 ways to choose a schedule with at least 2 math classes. Sorry about the confusion in that one. Moving on. How many 3-digit counting numbers are multiple of 2 or multiples of 5? Okay, well, we can think about this way. There are 900 3-digit counting numbers from 100 to 999. Of these, 1/2 are going to be multiples of 2. And 1/5 are multiples of 5. One half of 900 is 450, and 1/5 of 900 is 180. However, 1/10 of these numbers are multiples of 10. Which means they are multiples of both 2 and 5, and that's 90. So we're going to add up 450 and 180 and subtract 90. Okay, so 450 plus 180 is 630. 630 minus 90 is 540. There are 540 3-digit counting numbers that are multiples of 2 or multiples of 5. A single card is drawn from a standard 52-card deck. In how many ways could it be a heart or a king? Okay, well, there are 13 hearts. There are 4 kings. But 1 is the king of hearts. Which means we add these 2 numbers together and we subtract 1. We get 16 cards that are hearts or kings. Then we address in how many ways could it be a club or a face card? Well, again, there are 13 clubs, but there are 12 face cards. The Jack, Queen, and King of each suit. But then we've got 3 that are club face cards. That's 13 plus 12 is 25 minus 3 is 22 ways. Last problem. How many subsets of a 25-element set have more than 3 elements? Well, we can figure out how many subsets there are. That's 2 to the 25th power. And if I raise 2 to the 25th power, Do this over on Desmos. Breakfast of Champions. That number is 33,554,432. That is a lot of that's a lot of subsets. Now we need to figure out how many of these subsets have 3 or fewer elements. Okay, well, that's going to be, okay, we can take one subset with 0. 25, choose 0 is 1. That's the empty set. 25, choose 1 is going to be 25 factorial over 24 factorial times 1 factorial, which gives us 24. 25, choose 2 will be the number of 20 of subsets of size 2 or 2. So that's 25 factorial over 23 factorial times 2, which is the same as 2 factorial. So that's going to be 25 times 24 over 2 is 25 times 12, which is 300, if I'm not mistaken. Yes, that is correct. And finally, we've got 25, choose 3, which is 25 factorial, over 22 factorial times 3 factorial, which is, of course, 6. Okay, well, that's going to give us 25 times 24 times 23 over 6. Okay, well, that's 25 times 4 times 23, which is 2,300. Okay, the sum of all of these, 2,300, 2,600, 2,625. There are 2,625 subsets with 3 or fewer elements. We want all of the other subsets, so that's going to be 33,554,432 minus 2,625. Okay. It's going to be, let's see, 12 minus 7. It's 2 minus 2 is 0. Or minus 6, 14, that's going to be 8. I added one wrong. This should have been 25, not 24. There we go. So this should be 25, 26, which only makes this 1 less. That should be a 6. And then we've got a 1 here and 5, 5, 3, 3. 33,551,806 subsets with 4 or more items, 4 or more elements, or more than 3 elements. That's it for this video. If you have any questions, please get in touch.